Okay, so we're going to go ahead and fill out a unit circle. We're going to fill out all the degrees all the way around the circle, all the radians all the way around the circle, and all those little points. You see those little X, comma, Y points? We're going to fill out all of those. You should be able to do this in 10 minutes or less when I give you a unit circle quiz. Okay? Let's go ahead and start with degrees. When I very first... Somebody stole my black marker yesterday, and I forgot to give it back. That kind of sucks. All right, anyway. When I very first start, how many degrees am I at? Louder! Brooke, stand at 4. 0. If I go all the way around, where am I at? 360. All right. So if starting is at 0 and all the way around is 360, what's halfway around the circle? So this is 180 degrees right here, right? What if I wanted half of that? So if I start at 0 and I go straight up, what degree is that? So every time I cut my circle into a fourth, I'm going up by 90 degrees. I go 0, I go 90, I go 180. What's down here? 270 plus another 90 more is my 360, right? It should all kind of go together. All right, let's cut it again. If I go from 0 to 90, what if I cut it in half? So what's half of 90? 45. So now every time I cut it in half again, I'm going up by 45 degrees, right? So this is 0, this is 45, this is 90. What is this? What's 45 more? 135. What's 45 more? What's 135 plus 45? 180, right? Shouldn't it go together? It should all of a sudden click. And if it doesn't click, then you know you did something wrong previously. So now I'm at 180. Now I need to add another 45. What's 180 plus 45? What is it? 225? Okay. What's 225 plus 45 more? 225 plus 45 more, isn't that 270? And it should, right? So it's a way to make sure that I got it right when I can fill out the major ones. So then what's 270 plus another 45? 315? What's 315 plus another 45? Hopefully 360, right? Okay? So you can fill out those major ones. Now let's cut it again. Okay? I'm here at 0. I'm here at 90. What if I want to cut it into thirds then? If I want to go here and here. If I want to cut it into thirds. What would this first angle be? Third of 90. Isn't a third of 90? Isn't that 30? So every time I go up now, how many degrees am I going up? 30. You ready? I go 30. What's 30 more? 60. What's 30 more? 90. I can double check that I put one of those major ones. What's 90 plus 30? 120. What's 120 plus 30? 150. What's 150 plus 30? Perfect. I hit one of those major ones, right? What's 180 plus 30? 210. What's 210 plus 30? What's 240 plus 30? 270. Perfect. I've made sure that I've hit right one of those major ones. What's 270 plus 30? 300. What's 300 plus 30? 330. What's 330 plus 30? Perfect. Okay? You should be able to do all degrees all the way around your circle quickly so that you can do all of it in 10 minutes or less. Do you have any questions so far on the degrees? You see how I kind of sliced it into pieces first? I went around and I did the major ones, 90, 180, 270, 360. Then I cut those in half, so then every time I was going up 45, 45, 45, 45, 45. Then I did to give my 30s. Okay, to me that's the fastest, easiest way to do the degrees. Okay, let's talk about radians now. Okay, when I first start off, I'm at 0 radians. Do you remember from our discussion yesterday, all the way around the circle, instead of saying 360 degrees, what would it be in radians? Remember, all the way around isn't 360 degrees, it's 2 pi radians. So all the way around the circle is 2 pi radians. This is probably the hardest part because we're going to start getting into fractions. Okay, so if you'll kind of concentrate, pay attention to this. If all the way around is 2 pi's, then what's halfway around? 1 pi? If halfway around is 1 pi, then what's half of it? 1/2 pi. Can I say pi over 2? They're going to write it. So if this is 0, and then I go up by 1/2, then I go around again 2 halves, down here is going to be 3 halves, 1.5 if you think of it that way. So I'm going up now by 1/2, 1/2, 2/2, 3 halves. Then one more time is 4 halves. Doesn't that reduce to 2 pi? Are you okay with the blue so far? Now we're going to cut it again. Ready? If this is 0, and this is pi over 2, let's cut it in half. What's pi over 2 divided in half? Instead of dividing by 2, could I multiply by, please don't say 2. Dividing by 2 is the same thing as multiplying by what? 1/2. So if I take pi over 2 and cut it in half, where am I at? Pi over 4. So now every time I cut, I'm going to cut by pi over 4 by 1/4. You ready? I'm 0. I'm 1/4. I'm 2/4, just reduced. Then I'm 3/4. Then I'm 4/4. Then I'm 5/4. Then I'm 6/4, just reduced, right? Then I'm 7/4. And my last one would be 8/4, which is the same thing as 2 pi, correct? So going up by a 4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and I just make sure I reduced them all the way around. Are you okay so far? Just like we did degrees, we're going to cut it again. Okay? If this again is 0, and this is pi over 2, if I want to cut it into thirds, I want to take pi over 2 now, and I want to divide it into 3. Instead of dividing by 3, though, can I multiply by 1/3? So now, every little slice is going to be pi over 6. Ready? This first one, then, is going to be pi over 6. Now, you could, from yesterday, take the 30 degrees, multiply it by pi over 180, and reduce and convert it to radians like we did in yesterday's homework. Then you could take 45 and convert it to radians like we did in yesterday's homework. Then we could take 60 and convert. That would take a long time. You're going to run out of time. Okay? So hopefully, if you can quickly memorize 1/4, 2/4, 3/4, 4/4, you can do this in a timely manner. You need to be able to do it in a timely manner. Okay? All right, so again, every time we slice now, we're slicing by 1/6. Are you ready? Here's 0. Here's 1/6. Here's 2/6. Let's reduce, though. What does 2/6 reduce to? Can I say pi over 3, 1/3? You need to start again. Are you ready? 0, 1/6, 2/6. 3/6. Doesn't that just reduce, though? What is this guy? 4/6. 4/6. Reduce him. 4/6 is really 2/3. 4/6. Who's this guy? 5/6. Thank you. This one is 6/6. Isn't that okay? He reduces to 1. So I'm at 6, 6. Who's he? 7, 6. Who's he? 8, 6. Let's reduce him. 8, 6. 8, 6. 8, 6. 4 over 3. He's 8, 6. Down here, he's 9, 6. Doesn't he reduce? 9, 6 reduces to 3 over 2, so we're good. So I'm at 9, 6. What's my next one? 10, 6. 10, 6 reduces. 10, 6 reduces to 5 over 3. 10, 6. Here is 11, 6. And the last one would be 12, 6. 2, 5. So if you can fill out the major ones, hopefully they'll catch you. If you accidentally make a mistake, you'll get caught at those major ones and it won't match up right. And then you know you did something wrong. Okay? Please, please, please always make sure that you reduce. You should be able to fill out degrees and radians all the way through. Do we have any questions before we start filling out the points? Can you do it? Once you get in that little routine or like the pattern, it'll kind of go quicker. But what happens if you mess up on like this guy? Don't you mess up on everything if you're using him to start with? Okay, so you've got to be really careful. So the only way that you're going to get better with this is practice. Fill them out a bunch of times. You'll get into the routine, into like the little hang of it, but you have to make sure that you practice. Okay, let me show you. I'm going to do this. Or not. I'm going to have to erase all this by hand. All right, let's do the points all the way around, and I'm going to show you what do those points even mean to us. I'm just going to focus on this first quadrant for right now. You see that? From the center to the side of my circle. From the center to the side of my circle. Isn't that a radius? And do you see this from this center to this side of my circle? Isn't he also then a radius? And what do you know about all radii of a circle? It should be the same, right? Okay? So these two blue lines, these two radii are equal. They should be the same. What did we say this angle was right here? We said it was a 30-degree angle, didn't we? So if I put that little 30-degree in there, and I drop down and make a right triangle, woo, what did I just make? Didn't I just make a 30, 60, 90? Okay? Now, it doesn't go all the way out. So you see that? So this amount here is different than my radius amount. Do you agree with that? There's a little bit more that's not really covered. Okay? But this is a 30, 60, 90 triangle. Let's use our formulas. Across from my 30 is x. Across from my 90 is 2x. And across from my 60 is x rad 3. Since I don't know any of the sides, to make it easy, I'm going to call my radius 1, just to make it easy. I'm going to say that this is 1 unit. I'm going to say that this is then 1 unit. So if my radius is 1 unit, that means this side is equal to 1. If my radius from the center to the edge of my circle is 1, just to make it easy, I'm going to say that that side equals 1. So then do you see the equation I just made? I have an equation that says 2x equals 1. Could you solve that equation for me and get me an x equals? What would x equal? 1/2. If x equals 1/2, then what's this side opposite of my 30-degree angle? Isn't he 1/2? And if x is 1/2, then what's the side across from my 60-degree angle? Isn't he 1/2 rad 3? Or can I say rad 3 over 2? It means the same thing. That makes sense? So then if I'm trying to fill out this point right here, you remember a point is an x comma y. That means how far on the x did I go and how far on the y did I go? How far on the x then did I go? How long is this green little line? Isn't he the same as the side of that little triangle? He's rad 3 over 2. So this is my x, rad 3 over 2. How far on the y did I go? How far is this little green one? 1/2. Right? Does that make sense? So I use my special right triangles. Okay. I'm going to erase my 30, 60, 90 for now. And I'm going to do the next point. My next point is, where am I? What is that? 45? It's a 45-degree angle. What is that blue line? Is that a radius? And can we call the radius 1 again, just to make it easy? Okay. If I drop down a triangle, a right triangle, what type of triangle did I just make? Didn't I just make a 45, 45, 90 now? And we're going to call, you said, our radius. We said that this line here was our radius and he was 1, just to make it easy. Let's go around and let's do our special formulas. Across my 45 is what? X. Across my other 45 is X. And across my 90 is X rad 2. You see that little equation that I just set up? X rad 2 is equal to 1. It's not as easy to solve as the other one, but we can still solve it. Let's off to the side solve for X. If I'm trying to solve for X and I want to get rid of that rad 2 away from the X, can I divide both sides by rad 2? I'm going to divide this side by rad 2, this side by rad 2, so that they go away, but I don't like it. I don't like that radical on the bottom. So can we rationalize? Can we multiply both the top and the bottom by rad 2? And I end up getting X equals what? Rad 2 over 2? Okay. If X is rad 2 over 2, how far on the X did I go? How far is that little red line in my triangle? Isn't he rad 2 over 2? How far on the Y did I go? How big is that little side of my triangle? Isn't he also rad 2 over 2? So can I fill out this point? Isn't he X comma Y? He's rad 2 over 2, comma rad 2 over 2. Austin?
So like, you know how you insert 1, is that going to depend on how long the radius is when it's given?
No matter what the radius is, you will always get these same answers. They would just end up reducing them. You could have called your radius 2, and then you would have gotten 2 rad 2 over 4, and then you would just reduce. So it would always reduce down to these numbers. I just used 1 to make it easy. You could have called it whatever you wanted to.
Okay.
Yep, good question. What other questions do you guys have so far? Okay, I'm going to do one more quick one. The nice thing about the unit circle is once you can get one quadrant set up, then the other ones are the same. Or at least they're symmetric. They match up. Okay? Let's do one more. What is that blue line? He's also a radius. Can I call him 1? If I go to draw a triangle, a right triangle, what was this angle here, this blue angle that I just made? Isn't he a 60-degree angle right there? So what did I just make? Another 30, 60, 90. It's a little bit different, a little bit crooked compared to the other one, but it's still a 30, 60, 90, isn't he? Across my 30, X. Across my 90, 2X. Across from my 60 is X rad 3. Could you solve for X? Could you take this little equation if we said our radius was 1 and say that X equals 1/2 again? If X equals 1/2, how far is this line? 1/2. How far is that line? If X equals 1/2, isn't he 1/2 rad 3, or can I say rad 3 over 2? So on the X comma Y, I can fill out the point and say 1/2 comma rad 3 over 2. You could technically go around the circle and do every single triangle for every single angle. That's going to take you a long time. Okay? So let's try to think of ways, patterns, similarities for these points. Do you notice any similarities?
On the 30, 60, 90 triangles, the X and Y's are switched.
The X's and the Y's are switched. On my 30 and my 60, I have the same values, they're just flip-flop, yeah? Okay, that's good. What else? Also?
It goes from rad 3 to the rad 2 1.
Oh, pattern. 3, 2, 1,
And then 3.
and then 3, 2, 1. That's a pattern. That's a way to help you memorize. Instead of drawing those stupid lovely triangles, you can memorize a pattern instead of doing all that other stuff, right? What else do you notice, Austin?
All the denominators are the same.
All the denominators are what? 2. You can set up 2's all the way around, and then you just have to remember 3, 2, 1, 3, 2, 1. Right? Okay? I'm going to fill out this point right here. I went over 1, I went up 0, so that point is 1, 0, correct? This point up here at the 90-degree angle would be what? I went over 0, I went up positive 1. Over here at the 180 degrees, I went over how many? Negative 1, correct? How many did I go up? 0. Down here at the 270, how many times did I go over? 0. How many times did I go up or down? Negative 1. Okay? If you can fill out this first quadrant, you should be able to fill out all of the other quadrants because they're symmetric. I'm going to take this green one at the 30 degrees and I'm going to come over here and fill out the same exact one. Because really, isn't this just another 30, 60, 90 triangle? It's just flip-flopped if you're using your reference angles, right? So instead of drawing that whole triangle and doing it all over again, can I just bring it over? But there's something missing. What's missing? A negative. Don't I go left on the X? I have negative. You could, on this guy, do another 45, 45, 90 triangle. Technically, he's just flip-flop. Or I can bring this guy over. Please don't make that noise when you're taking your quiz.
Yeah.
What am I missing? Just the negative. So then can you fill out this guy? Can I say that? Negative 1/2, comma, rad 3 over 2. If you can fill out those, you should be able to fill out the rest of them. If this is a little 30-degree triangle, then isn't this going to be a 30, 60, 90 triangle? So if I can fill out this green one at the 30, can I drop it down here? What am I missing? A negative on the y, 1/2. Please make sure I can clearly see your negative and your positive signs. If I can't see it, I mark it wrong. So then what would this one in the middle be? Rad 2 over 2, comma, negative rad 2 over 2. And then the last one's going to be a 1/2, comma, negative rad 3 over 2. Just symmetric. You can fill out the first quadrant. You're just sliding them over, sliding them down. You ready? What do you think this one over here is going to be? Rad 3 over 2 first. If I just slide it right down, slide it over, slide it up, they should all match. Rad 3 over 2, comma, 1/2. What are we missing? 2 negatives, right? Negative x, negative y, 2 negatives. Okay? Filling out this one, I have a rad 2 over 2, comma, rad 2 over 2. Both negative. Filling out this one, I have a, who goes first? Negative 1/2, negative rad 3 over 2. Do we have all the points filled out? Do we have all the degrees filled out? Do we have all the radians filled out? You should be able to do that in 10 minutes or less. Okay? Not by drawing the triangles and doing your special right triangles, but seeing if you can find a pattern. We did it with the angles where we cut it. We did it with the radians where we cut it. And so now what other patterns do you see? Well, first of all, you can figure out positive and negatives, correct? If I'm going left, down, up, right, they're positive or negative. But you should also be able to see that all my denominators are the same. They're all 2s, so put them all. And then all you have to do is worry about the top number, okay? You can either memorize patterns as 3, 2, 1 or 3, 2, 1 like that, okay? Or what I remember is this is a what degree angle? 30, and 30 starts with a 3, so this first one starts with a 3. So I know he is the one that starts with a rad 3 over 2. Because what happens if you flip-flop these and you accidentally do a 1/2 comma rad 3 over 2 for this 30-degree angle? You not only mess up on quadrant 1, don't you mess up on everybody because we've just now copied it for the rest of the unit circle? You screw up everything, okay? So it's super important that you place them right, especially in quadrant 1, because we're going to be copying it to my other quadrants. Okay? Right. Do you have your little chart still that has those 9 numbers in it somewhere? Was that in chapter 2? Do you have that, those notes that we can look at real quick to show you? Can you take that out? Because what's the point of all these numbers? What's the point of all these points? What do they even mean? Sounds like it looks like it's way more complicated than it is helpful. Let me show you why. If you can find that little chart with the 9 numbers, if you've memorized it, awesome. Where you have the sine of 30 and the sine of 60 and all that kind of stuff. What is the cosine of 30 degrees on your chart? Rad 3 over 2. The cosine of 30 degrees. The cosine of 30 degrees is rad 3 over 2. What's the sine of 30 degrees on your chart? 1/2. So the cosine of 30 degrees is rad 3 over 2. The sine of 30 degrees is 1/2. You notice anything on your unit circle? The cosine is rad 3 over 2. The sine is 1/2. Let's do it for the 60. If I'm at the 60-degree angle, what's the cosine of 60 on your chart? 1/2. What is the sine of 60 on your chart? Rad 3 over 2. Do you notice anything? Any sort of patterns that I'm hinting at using your unit circle? Let's do 45, 45 then. If I'm looking at this 45-degree angle, what would you say the cosine of 45 degrees is? Rad 2 over 2? What is the sine of 45 degrees? Rad 2 over 2. So what do you notice about the points on your unit circle compared to the sine and the cosine of any angle? What do you mean the same? Who though? So if I wanted to find the cosine of 30 degrees, and instead of looking at my chart, could I use my unit circle? If I wanted to find the cosine of 30 degrees, who would I look at using my unit circle? Guys, if I wanted to find the cosine of 30 degrees, instead of using my chart, I should be able to use my unit circle. Here's my 30 degrees. Who would I look at? The x sine. Isn't the cosine rad 3 over 2? And what's the sine? 1/2. Does that work all the way around your unit circle? Does that work for the 45, 45, 90? Cosine of 45 is rad 2 over 2. Sine is rad 2 over 2. The cosine of 60 degrees is 1/2. The sine is rad 3 over 2. So then if I were to ask you, to find me the cosine of, I don't know, 300 degrees. I want the cosine of 300 degrees. Yesterday, what did we have to do? We had to draw the picture, we had to figure out what quadrant it was in, we had to draw the right triangle, we had to find the reference angle, we had to do our 30, 60, 90, we had to do our adjacent over hypotenuse. Now, you should be able to look at your unit circle, find 300 degrees, and tell me the cosine using what value? The x value of your point. Find 300 on your unit circle. Find the cosine of 300 degrees. What would you say it is? 1/2. Right? Isn't that way faster than having to draw all the triangle and do all that craziness? Okay? Find me the sine of 7 pi over 6. Find me the sine of 7 pi over 6. What would you say the sine of 7 pi over 6 is? -1/2. Do you remember how we had to do it yesterday on homework? Didn't we have to take that 7 pi over 6, first convert it to degrees, then draw the picture, then draw the triangle, then do my special rectangles, then do my SOHCAHTOA? It took forever, right? Now, you should be able to look at your unit circle and you automatically give me sine and cosine. Okay? Again, where do I find the cosine value at? X value. Where do I find the sine value at? Y. You should be able to find the cosine and the sine of all of those degrees or all of those radians. Now, if it's somewhere in between, that's a little more tricky. Okay? Well, let's focus on those. You should be able to fill out a blank unit circle. Degrees all the way around, radians all the way around, and points all the way around in 10 minutes or less. The only way that you're going to get good at that is practice. I'm going to give you 4 tonight for homework. I want you to try and fill it out without looking at the one we did in notes. The more you do, the more you're going to get better at it, and the better your homework is going to be for you. Okay? So do you see the patterns? See the patterns? Okay, so just be careful. If you mess up on one, it messes up everything else. I'm also going to show you a cool trick I found on YouTube. It's not a dance. I wish it was. It's a trick with your hand to do unit circle. I don't know. I think it's pretty cool. I'll show you next week.
All right.